Just some quick vocab that I'll be using today, and I want to make sure you're aware of it. Old school graph paper. That's what you've been using most of your math career. Anytime you plot a point on there, that's referred to as a rectangular point. I'm going to be using this word a lot today. All right, rectangular point when you put it on the XY axis. You guys know, what do we call it now on this grid? It's not a rectangular point, it's a polar point. Yep. Rectangular points come in what form? What comma what? X comma Y. And a polar point comes in this form. You got an R value and then your angle. Here's what I'm going to do with you today. Give you a polar point. What is that point but on this grid? So basically going from our angle to XY. Right? That's our goal today. Get a polar point. What's it look like on the rectangular grid, and graph both of them. All right, let's start off. First one. 2 comma 3 pi over 2. Day 5. First thing I want you to do, graph it. We should have no issues there. Go ahead and graph 2 comma 3 pi over 2 on that first polar grid right there for me. So what do we have to multiply by first?
6.
6. Good job. Multiply by 6. So I really ask you to graph 18 pi over 12. Clockwise or counterclockwise? Counter. Make sure we count up to 18, right?
Wait, so how many are it? So it's like 20.
24 total. So right here you got 6. Halfway you got 12, 18, and then back to 24. So our angle here is going to be looking like this, right? And again, you guys know this. You don't have to draw the angle. All right, some of you are at the point now where it's like, I don't need the angle. I could just graph the actual point, and that's it, which is fine. Fine. All right, so 2, do I have to go in the opposite direction?
No.
Nope, it's not negative, so here's my point. So now what I'm looking for today is what's that point on the rectangular grid, on the XY axis. First day we did this, I asked you guys like a magic eye type question. Can you see the XY axis on the polar grid?
Yeah.
All right, don't draw it in. I'll draw it in. It's right here. Right? All right, what's that point on the rectangular grid then? X as X comma Y.
0.
What's that point on the rectangular grid right there? Can you guys see it on the rectangular grid?
0, -2.
0, everyone agree? 0, -2. There you go. You just converted your first point. And now what I want you to do on the rectangular grid is graph 0, -2 for me now. So you guys just converted your first polar point into rectangular. Wasn't that bad. 0, -2. That's pretty convenient when it lands on the line, right? Do you think it's going to land on the line? Nope. So we got to have some other way of doing this if it doesn't land on the line and it's not so easy to see its coordinate. Any issues how I got this polar point and figured out it was 0, -2 on rectangular?
No.
Everyone see where it was? 0, -2. All right, what happens if it just falls in the quadrant now and not on the line? We got to do something different. So here you go. Part B. Can you guys help me graph -8 pi over 3? What do you multiply by?
4.
Yep, 4s.
4 pi.
4s. So you guys are multiplying. You guys are doing -8, 4 pi over 12. One, 2, 3, 4 right here. And before you go graphing it, what's the deal? -8. Opposite. Yep. Got to go opposite. I think there's always 10 total circles here. So I'm going to go right there. We're good? All right, let me draw my XY axis again. And anybody, what's a little bit different now?
It's not.
Anybody going to tell me what that point is? I don't think so. Right? The basic you could tell me is in quadrant 3. That's it. All right, but there's no way you're going to tell me what that point is. All right, so I got 2 formulas for you to figure out the x and the y coordinate. And they're on the top of the page too if you forget tomorrow. Here you go. To find the x coordinate, to find your x coordinate, here's what we're going to do. We're going to take the r value. You guys know where that is. The r value and multiply it by the cosine of the angle. Everything's there. And this is all calculator. You don't need to get freaked out here. I'm not going to do anything special. Ready? What's your r value here?
-8.
-8 times cosine. What's the angle you graphed?
4 pi over 12.
Or pi over 3?
You can do either, right?
Okay, before you go to your calculator, though, you got to be aware of something. Pi over 3 is in what units? That's radians. So guess what your calculator's got to be in if you're going to type this in? Radians. Anybody know where to go to change it? Mode. Hit your mode button. Hit your mode button. Now get in radian mode because pi over 3 is in radians. If it was a degree, you'd go to degree mode. So just be aware of what mode it's in. So I do -8 times the cosine of pi over 3. And I'll tell you what the x coordinate is. Should be a nice whole number, I believe. What are you getting out?
-4.
-4. Anybody not getting -4? So we can help you with your calculator.
Where's
Anybody need calculator help here? Make sure you're in radian mode. All right, and then how do you find your y value? Pretty similar, except now you do r sine angle. R times the sine of your angle. That's it. Cosine for x, sine for y. So we'll do -8 sine of pi over 3. Make sure you're in radian mode. And you are going to get a decimal here, and I'll let you know the rule when you get to that decimal. We'll just have a consistent class rule, and that is nearest 10th. All right, let's all round to the nearest 10th every time. Consistent class rule. Unless anybody wants to go up further. I didn't think so. -6.9. And go ahead and graph. Oh, go ahead, Lizzie.
If you were to like change it to degrees, can
You would have to convert your radians to degrees.
Would it still be -8 cosine and then degrees?
So in this case, -8 cosine 60 degrees.
So
And make sure your calculator's in
that would
degree
work,
mode.
though?
What's that?
It would work the same.
Yeah, no issues. Just make sure your calculator's in the right mode. All right, go ahead and graph that. And this is why I have you graph it every time. It's a good check. After you're done graphing, look at your polar point and your rectangular point, and we should be in the same area code here. All right, we should be in the exact same spots. -4. 1, 2, 3, 4, 5, 6, 7, almost. Yep. 6, almost 7. And now compare the two. Pretty close if I put one on top of the other, or exact. All good? Any questions? Now, hey, could I have done this to the first problem? If you don't notice it's on the line and what it is, yes, you can. This would still come out to be 0, 2. All right, so these 2 formulas work for any time. All right, one more, and then we got to review some stuff from early in the school year. All right, 2, 7 pi over 6. Graph it on the polar. Graph that polar point. Multiply by
2.
Yep. So you got 2, what we got there, 14 pi over 12. Remember, halfway all the way around, halfway is 12 pi. 13, 14 pi. No need to go backwards. And I don't know about you. Let me check real quick. I don't think we're going to be able to just tell what that point is. Nope, it's not on the line, so we're not going to be able to tell. All right, here we go. X coordinate. R cosine angle. What's your R value? R value? 2 cosine 7 pi over 6. The only thing you got to worry about, pay attention to what units the angle's in. And then you're going to know our rule from the last problem, nearest 10. Negative 1.7, that's it. And then the y coordinate, r sine theta, not that bad at all. 2 sine 7 pi over 6. And that's a nice number, I believe. Got there, -1. Yep. There we go. And again, good check when you graph it. We should be in the same area from the polar and the rectangular. -1, down 1.7. Looks pretty good. Shoot, I graphed that wrong. Over 1.7, down 1 right there. Good. Questions, comments, concerns? So that's basically the new stuff I got to show you, and we got to review some stuff from November because it's going to come up again in my next lesson. So let's do it now. You guys, anybody remember these reference angles? Graph 160 for me, please. Just to do a quick sketch. XY axis, no polar grid, just XY axis 160 for me. See if we remember this at all. What quad you graphing in?
Second.
Darn right. Closer to 180. Not even going to bother asking anymore. Remember the reference angle. Okay, the reference angle is first part of it's that terminal side you just graphed in. And anybody remember which axis? The X or the Y axis is my reference angle on. X. Always X. Always. I should never be highlighting the Y axis. Always the X axis. Can you help me find what that angle is? Because it's your reference angle.
Oh, subtract.
How can I find that angle right here? All right. Where? First of all, where are we here? What's that angle? That's a buck. This is a $1.80, right? And you just graphed 160 degrees. What should I be doing with the two? 180 minus 160. That's a 20-degree reference angle. Real quick recap of reference angles. Always positive, always between 0 and 90. Always positive and always between 0 and 90. All right, where's 300? 300, quadrant 4. There it is right there. Okay, do you see the reference angle at all? First thing I always do, I always highlight that terminal side. And what axis again? X. But let's think about it. I don't want to go that way, right? Because this angle's got to be 90, less than 90. So I need the smaller angle when I highlight the x-axis. There you go. Help me find that angle.
So you can just go either.
I don't want to use 180 this time.
360.
I don't want to use 270. Never 270 or 90 because I never use the y-axis, right? Never use the y-axis, so I don't need 90 or 270. I just need 180 and 360 in this case. And what do I do? Add or subtract? If I added 300, that'd be kind of ridiculous because that'd give me an angle way bigger than 90. 60 degrees. Cool boy. What's your issue with 3? Oh, then it's just math.
It's uneven.
What anybody's issue with 3 or C?
In
Oh, in radians, yeah, in radians. We've just been dealing with degrees. Is there any way I can change it?
Yeah.
All right, let's change it then. Make our lives a little easier. How do we change?
Times 180 over pi.
Yep. Cross them.
So it's.
Remember, you're not cross multiplying. There's just multiplication, not cross multiplication. 5 times 180 over 6 or negative 5/6 times 180. No cross multiplication. Negative 150.
Wait, so we get.
Negative 5/6, and then I multiply it by 180. No more pi's because they canceled out.
Oh.
All right. All right, real quick here. Where's negative 150? Uh-oh, got to go travel clockwise now. Where are you? Where'd you end up? Where did I end up?
4.
Oh boy.
Wait.
Negative 90, right? I'm going clockwise because it's negative. Negative 180. Can I stop?
Yes.
Quadrant 3. Yes?
When it's negative, you just reverse the order, right?
That's what we've always been doing, right?
Yeah.
No matter what we're doing in this class. You always go clockwise when it's negative.
No, I just mean with the numbers.
Reference angle. Terminal side. Everyone see what axis? The x-axis I'm going to highlight. Make it in between 0 and 90. There it is. All right. A little help for that angle. Don't let the negatives affect you either. It's still 180 and 150 whether I go, no matter what direction I go in. This reference angle.
30.
How'd you get 30?
180 minus 150.
As beautiful as this all looks, not correct, not finished.
Put it back in radians. Wow.
If I started in radians, I got to end in radians. Okay, if I start in radians, I know that's a pain, but I do have to end in radians. Pi over. And go ahead, leave your pi in your answer and reduce 30 over 180. You guys are becoming pros at all this basic stuff here. Whew.
Pi over 6.
So we're at pi over 6 for my reference angle. Who's on top of their game with this last one? 78 degrees. Relax. What quad you in? Oh, please help me on this. Thank you. Thank you. Do you see your reference angle?
Yes. Shut up. That's what it means. Isn't it the same thing?
No, Liz, Libby.
When you're in quadrant 1, what do you know about the reference angle?
The same.
It's the same as the original, correct?
Oh, I wrote the answer wrong. I wrote 75.
78. Yep. It's its own reference angle. Any questions finding the reference angles now? We're going to go backwards now and we're done. This will see who's on top of their game. Okay, here's the deal here. I'll give you the reference angle in the quadrant. What was the original angle now? Okay, so basically going backwards now. I'll give you the reference angle and the quadrant. What must have been my original angle? All right, so for this first one, you guys see we're in quad 2 and a 70-degree reference angle. Do you think you could draw that?
Yeah.
In quad 2, a 70-degree reference angle. In quad 2. Hey, I shouldn't be seeing any of this here. That's going to be bigger. That's going to be bigger than 70.
Oh.
I should be seeing this. Use this x-axis into quad 2. 70 degrees. Right? Need an angle less than 90. Now what I'm looking for is, all right, what's the angle then? Let's not, think about it, how I get there.
180 minus 70.
Let me try to help. I think this is a good way to help you guys out. This is what, first of all? How many degrees over here?
180.
180. Everyone agrees?
Yeah.
If I add something to it, where am I pushing my angle into?
The third.
Right here, quad 3. I want to push it into quad 2, so don't I want to take something away to make it smaller? Everyone see that, whether I add or subtract? If you add something to it, you're going to push it into quad 3. If you subtract, now we're pushing it into quad 2. And what do I want to subtract? 180 minus 70.
Wow.
Ends up 110.
So you're always going to stay in the quadrant. So like if the reference angle is in quadrant 2, then
Your answer should be in quadrant 2.
Okay.
Yeah. All right, part B. Oh, what don't you like about B?
It's in radians.
You know what? It is. And we're going to stay in radians because you can handle it. All right? You don't need to change the degrees. Watch why you can handle this. This is stuff we've done all this unit. I refuse to let you guys change it into degrees. And plus, it takes too darn long. What quad are we in? 3. Make a reference angle in 3. I don't care how big it is. Make a reference angle in quadrant 3. How big is this reference angle? Pi over 3. Don't change it.
Wait, how did you do that?
I'm in quad 3, and the reference angle is pi over 3.
How do you know the what?
I don't know what don't you.
How do you know?
What do you think I pulled out of thin air?
Pi over 3. Like how do you know that pi over 3 is in? Is it? It's in
No,
quadrant
how
3
do
because
you
it's 3.
know?
Wait.
I'm just reading the
How
directions.
do you know where it is?
Like
A
that?
reference angle,
But
right,
how-
is on the x-axis
If
and
it
the
was-
terminal
If
side.
it was on the other side being quad 4.
No, I know not the other side.
What do you mean? Why isn't it
How
here?
do you know that angle is pi over 3?
It's a
No, how do you
I know
just?
what you're saying.
Do you know what I mean?
Like why? How do you know it's not like this?
Yeah, how do you know
Like-
what side's closer to? I don't know.
It doesn't really, like, how did I know that was 70?
I don't know.
Like, why did I draw it like that? Like, you didn't have any, did you have any issue with me doing the 70 degrees?
Kind of, because it's in the middle and it should be closer to one
It
side.
doesn't
Okay, then that's fine then. Make it however you want to make it look.
So then
That's
what's
fine.
the point of even graphing it?
Just to see it in quadrant 3.
Okay.
I don't know what that's
Okay?
No, but how does that not make sense?
All right, I got to pick up my steam back here again. I need what this angle is in quadrant 3, right? You don't need to convert it, right?
2 pi.
Here we go.
Pi.
You guys told me, hey, in the previous problem, you just told me that was 180. Well, I'm not in degrees anymore. You know what 180 is, though, in radians, which is what? Okay, so that's pi now. Do I have to add on to it to get into quadrant 3 or subtract onto it? What do I need to do to pi to push myself into quadrant 3? I need to add on, right? And what am I going to add on? Pi over 3. All right, so my angle is going to be pi plus pi over 3. And don't even get me started.
No, we know. We got it.
You can handle that. We've been handling it all this unit.
Plus pi over.
You get a common denominator, which is what here? 3. What do you multiply this pi by?
Plus 3 pi over 3.
Do I need to multiply anything here? Nope. Plus pi. We've done this already this unit. So what's my angle?
4 pi over 3.
Now look, if you need to, sure, go convert it to degrees and convert it at the end to radians. We can handle it though. Are we okay while we're, I know there was some looks of confusion. While we're at, look, I'm at 180. If I need to back up, I need to subtract. If I need to add, or if I need to get into quadrant 3, I need to add on to it because I'm going this way.
So then where's your angle?
My angle's right here. 4 pi over 3.
And it's
Also known as, if this helps, 240 degrees.
Oh, okay, so it's that line.
It's from here
Yeah.
to here, but going this way.
Yeah.
All right. Other questions? One more, because I know one doesn't make us great. Now I'm in quadrant 4. Just draw a reference angle in quadrant 4. Just draw a reference angle in quadrant 4 for me. X-axis and terminal side.
I did it.
Here you go. X-axis, terminal side. It's pi over 7. What do you need to find? What's the angle in quadrant 4?
Oh, 2 pi.
So now instead of working over here, I'm going to work over here, which is usually 360, also known as what? Because we're in radians?
2 pi.
Okay, now think about it. If I add something to 2 pi, what quadrant am I pushing myself into?
The non-existent.
Quadrant 1, which I don't need. I need to push myself
Subtract.
back into quadrant 4, so I want to subtract now.
2 pi.
Yes? 2 pi
Minus
minus pi over 7.
14. No, but then it's 14. So you do times 7.
So you get your common denominator, 7.
You'll see.
It's not 14.
No, 14 pi over 7.
Multiply it by 7.
The answer.
No, you'll see. That's not the answer.
14 pi. Hey, do I need to multiply this one by anything?
I know it's not the
No.
answer.
Nope.
I know it's not the answer.
So the angle ends up being 13 pi over 7. You don't need to change it into degrees when you find that angle. All right, I'm good. We'll be back tomorrow for the assignment. Thursday is a review day. We are going to review. Friday's the quiz. We got to review. We got to review.
Other than this, I thought it was good. This is the. I literally only came to school for this class.
Darn right you do.